Hello, Jen.
Hi.
How's it going?
I'm doing all right. How are you?
Doing pretty good. We have our guest right here.
That's so cute.
Say hi. Wave. Wave.
Oh,
Her name's Jen. Okay. We're kind of foggy, it looks like, but
a little bit, but still, she's so cute.
yeah. Thanks.
What's her name?
Samantha.
Hi, Samantha.
Here, I'm gonna take you unplug so she can say hello. Say hi.
Hi, Samantha.
Say hello.
How old are you?
Hi.
How old are you?
2.
You're 2?
Hmm.
You're such a big girl.
Hi, Johnson.
Yeah, you watching Mulan?
Mulan's a good show. Good choice.
I
Good
Like,
choice. It's good.
Mulan.
I'm sure Mom wants to watch Mulan too.
I know.
Instead of doing this.
Like, well, Dad's at a meeting, so you'll be my guest today.
It'll be great.
So. Thanks for coming again. I know you've got a busy week.
No, I didn't mind. I was just worried that we wouldn't get everything done. But it's fine. I just had our stake presidency. I'm really close to them because I'm the Relief Society president. And so they're getting released on Sunday. And so they had a big thing today that they begged me to go to. So,
Wow, okay.
yeah. So it was like a goodbye party from all the wards.
Oh, that's nice.
Yeah.
Are you
So,
sad that you're getting released?
yeah, they have been awesome. They're my favorite, and it's really sad that they're leaving.
Yeah.
But it's okay. Like they are ready to be released. You could totally tell they are so ready to be done.
Wait, your counselors or?
No, the presidency or the stake presidency. They've been in our stake for like 10 years, and so they're ready. Yeah.
Oh, I bet.
So it's just sad.
Yeah. So wait a minute. So you're getting released, and you're just you're the Relief Society president in your ward, or are you the stake Relief Society president?
I'm the Relief Society president in my ward, but my stake presidency and their wives I'm in a singles ward. So the stake presidency is being released, and it's a student ward, so their wives are the Relief Society stake presidency. Everybody's being released. So it's just, it's sad.
Any news on, well, not that you'd have much more from yesterday, but you're applying for your rate, whatever.
I have an interview on Monday.
Okay.
And so I have to do a 5-minute presentation. So I'm trying to decide what I'm going to do.
Woo!
I know.
Hello.
Hi.
Hey guys.
So Myra, I've been meaning to ask. And
Yeah.
I was gonna wait. So what was my problem? How was I not able to see the bird flu temps?
I don't know what you were looking at, but if you go to the exam, it's just one of the applications on there that you have to download.
Okay, because I was just looking on, like, I clicked one of the links that was in the reading from this chapter to look at the body temp, and then it gives you that huge list of, like, Excel documents and then the SPSS. I was looking at that.
No. I was taking the test today, and so I had SPSS pulled up, so I was ready for it, and then I started the test, and then I came across the questions that required that file, and then when I pulled it up, it just completely disappeared on me, and it kind of shut down, and I don't know, it just like was gone, and I was trying to re-download it. It was just so complicated, so I was like, I'm just gonna email her and skip it and go to the next ones and then come back to it.
Okay.
And she never emailed me, so that's when I texted you and asked you if you could send me the file if you had it. But Candace pulled it up.
Candace, where did you find it? Because I just don't want to, like, shoot my file back to where I was looking and not even find it. You know?
Yeah, no, you just go to the exam, and it's just one of the a paper, you know, it's just an attachment. Yeah.
Okay.
It's
I was
an
like,
attachment, yeah.
I can't find it.
Save file.
Yeah. Jenna didn't text
It's
you
a
because I
save
knew you were
file,
at work.
so you have to have
fine.
But yeah, I I don't know what's wrong with my computer.
But you were able to get it all done. Like, I was freaking out for you because I was like, she only has 4 hours!
I know. I was freaking. I expected her to email me fast because it's test date only today and tomorrow. So I kind of figured, oh, she'll probably be on her computer all day. But then when I didn't see her email, once I was done with the rest of them, I started to panic, and that's when I texted you guys, and I was like, I just need a screenshot of the file right now.
Yeah.
But
I'm
yeah,
glad it worked out.
I got an 88.
Hey, that's still pretty good.
So yeah, but I don't know. I studied like 10 hours straight and then took it, and so I was like, really? But yeah, I shouldn't complain.
You know, that's a pretty good score. So
Yeah. So I'm just so glad I'm done with it because it was really stressful.
I haven't taken it yet.
I'm taking it tomorrow.
I can. Yeah, I work 12-hour shift tomorrow, so I'm like, I have to take it today or I'm done.
Yuck.
So I'm not as prepared for this right now because I was just so tired, but I'm still gonna participate.
No, that's great.
Well,
Just don't be mad
this
at me if
section
I don't know.
for me was pretty confusing. I don't know about you guys, but I was confused.
Yeah, it was just a little flustered. Like, it just seemed like it didn't flow as well as the other ones.
Yeah. A little
Yeah,
scattered.
I watched both the videos and read everything, and I was still confused by some of the questions.
Yeah. What I was confused with, and I don't know why, but in the video where he gives you the 15 sample number, you know which one I'm talking about, the age group.
Yeah.
I don't get, like, on the video where he goes to an Excel and it automatically gives him, like, the data, like, I don't know how to explain it, the histogram, and then it also gives you, like, the standard deviation and all that, like, automatically. Do you know what I'm talking about? It's like a saved quantitative, what's it called? Quantitative descriptive statistics in Excel.
I don't know how to
talking
do
about?
that in Excel, but I know how to do that in SPSS.
Okay. Is it just like this quantitative descriptive statistics? Is that a saved thing?
So it's on when you're on SPSS, you have your data pulled up on that spreadsheet, and then on the top it's descriptive statistics, and you just go and you input the information. So those steps that you were just saying, you just do that on SPSS. It's like a drop-down bar.
Okay. I will figure it out because I was just like, I don't know how to do that. I was able to get like the histogram and stuff and all the other information, but not the way how easy it looked for him, you know?
Right.
So, cool.
All right. So if you guys want to get started on it, I have a few questions on like the part we were supposed to do by ourselves.
Okay.
So question 2, it asks if it's one-sided or two-sided, and was that like the same thing as one tail or two tails?
Yes, I believe so.
Okay, because I did not hear it called that, so I was gonna.
Wait,
Yeah,
what?
I'm pretty
Part
sure that
two,
they're the
what
same
number?
thing. 2.
Number 2. Okay.
Yeah, and the reason, do you know
Okay.
why it's one-sided?
So because it's just less than, you do one side, but if it was not equal to, it'd be both sides.
Right.
Okay.
Would it be one-sided? It would still be one-sided if mu was greater than the 0, right? It would still be one-sided because only the greater side would be highlighted.
Yeah, I think so.
Yeah.
So, and the way I got it is like the equal signs with the slash means it's two-sided.
Mhm.
So, okay.
I
Just making sure.
And what did you guys have as your definition for p-value? Because I felt like it was kind of like a weird, like number 6. Like I don't exactly know how to put it in words that make sense.
I put the probability of obtaining a sample mean at least as extreme as the one you calculated, assuming the null hypothesis is true. I'm pretty sure that's the same, I think that's the one I wrote down in my notes.
So can you guys like put it into your own words and explain it to me?
So the p-value is the probability of it. Like you use the p-value to determine whether you reject the null or if you fail to reject the null. So
Right.
your p-value is the statistics that you find based on the data you have.
Okay, because it, like, the way the definition is phrased, it sounds like you're doing probability for a sample that's different than the one you collected.
No, right, I see what you're saying, but no, it's using your data that you created, that you have, and determining whether you should reject the null or fail to reject the null.
Got it. Okay.
Okay.
And then when I was reading today, it made it sound like you're always committing an error. I was kind of confused on the two different errors.
So there's a type 1 error and a type 2 error. Let me pull up my notes here.
Like, how would you calculate them? Is it always given to you?
The error?
Yeah.
No, so depending on what you get for your p-value and depending on what you get for your math, you can determine what type of error it is.
So no matter what, you're committing an error?
Not necessarily. So if you look on the online textbook, if you go to section 4.5, the types 1 and the type 2 errors, they have like a little box. It's on the homework too.
Yeah, no, I copied it down, but then in the reading and examples, I was just getting really confused.
So it has to do with, okay, so if you reject the null, that means that your null is not true, but how do I describe it? It's hard to describe.
Because how I first understood it was that you have, basically, there's a chance you could, because of your data as a sample, you could find the wrong answer.
It's kind of like when you're doing this is the way my teacher described it last time I took this class. It's like if you're on trial and they say you're not guilty. You're not innocent. They can't prove that you're innocent, but they can definitely prove that they don't have enough evidence to prove that you're guilty. Does that make sense? So it's pretty common for I think it's the type 2 that, hold on, let me make sure. I think it's a type 2 where you can't prove that it's necessarily correct, but you can't prove it wrong. I don't know if that makes any sense.
Would it make it easier if you just thought in the way of, well, like, okay, I don't know. Never mind. I'm not even going to say it because I probably just screwed up.
That's how I feel. I'm like, I'm just not going to say anything. I don't know.
So
I'm
thought
so
of it as,
confused.
like, whichever one, like, you're going to have to reject one of them, I guess, right? In a good way. And, like, you just want the one that has the least bad outcome, I guess, right? So, like, for the proven guilty and not guilty, you would rather say that you'd rather have a type 1 error proving that the actual guilty person, I don't know, is not guilty, I guess.
Right.
I don't know.
Than convicting somebody who is guilty.
Yeah, so here's the sentence that confused me. I found it when you told me to go to the notes. It's in the 4.5, type 1 or type 2 errors. The second paragraph, it says, whenever we reject a true null hypothesis, we say that a type 1 error was committed. So you always make the error if you reject it?
Well, because if you reject the null, you can't prove it. That's what, or if you fail to reject the null, you can't prove it.
So is it more like a margin of error where there may
have been yeah.
Okay.
Because
that kind of helps.
You can't prove that it's true, but you can't prove that it's false.
Okay.
So basically, your alternative hypothesis, you can't prove that that is the result. So kind of like we did this in my class before, where it's like who puts shopping carts more frequently back into their stalls, men or women. And that was our hypothesis, and we couldn't prove either of them because the data didn't show. They both put their carts away, but we didn't have the adequate information to determine did men or women put their carts away. we couldn't say men did it more or women did it more because it was unconclusive. I don't know if that makes sense. But
Yeah, I think if I think of it as margin of error, it makes sense.
okay.
I'll probably email her to make sure that I understand it correctly.
Okay, that's
Yeah.
probably a good call.
Yeah.
Okay.
Okay, that was all my questions.
Yeah, the type 1 and type 2 errors are pretty hard to understand when it's not explained to you. And it's hard to explain it when you're,
Yeah.
like, second-guessing yourself.
Yeah.
Uh-oh, she made me nice.
Nice.
That is so
She's
cute.
saying Mushu needs to be nice. He's like fighting with the ghost, you know, that part.
That's so funny.
How old is she?
2.
She's so cute.
I just checked on it.
Was it done? Did you send it in?
No?
Sorry.
No worries.
Okay, so we can go through the preparation assignment.
Hey, let's do it. Should we start from part 2 or should we start from the beginning?
I checked my answers, so I know they're right now, and so you answered all my questions. So
Okay.
it's up to you guys.
I'm okay with starting at part 2 if everybody else is.
I am.
Yeah.
Okay. So part 2A, determine the null and the alternative hypothesis. So the null is that the mean is 529. The professor thinks that scores have improved, so we think that our alternative hypothesis is that it's greater than 529.
Yeah. That's what I have.
Does that make sense?
Yep.
B, so we should reject. There's evidence to suggest reject the null, but in reality the scores are the same. So it committed a type 1 error.
Yeah, I just used that chart.
Yeah. That's basically how I did it too. You just look at the chart. It's easy that way. Okay.
Yeah, and so
Oh, go ahead.
so C is a 1% chance of the error or a 0.01 probability of it happening.
Correct. And it says that in the notes, I believe. I
Yeah,
read that.
that's where I
In the
figured it.
textbook, that's where she said it. Okay. So D. What would increase or decrease the level? I think it would increase the level of significance.
So can you explain that to me? Because I thought it was decrease, and then I looked it up, and it was increase.
So decreasing the probability. So explain to me what a type 2 error is.
So type 2 error is when you, hold on, I need to look at my chart. So it's when you don't reject the null, but you should have, basically, because the alternate hypothesis is true.
Okay, so if you if the probability of it, if you decrease the probability of that, then the significance of the decision is increased. That doesn't make sense.
Well, in
As
the
I'm
video, he's like, if you increase it or decrease it, it's just a balancing act.
Oh, so it would be the opposite.
So because you decrease one, you have to increase the other. But if it had said decrease the probability of a type 1 error, wouldn't you want, then you need to decrease it?
Then you'd want to increase the type 2 error. If you're needing to decrease the type 1 error, then you'd increase the other one.
Well, the level of significance I thought was equal to the p-value. Is that wrong?
I am not 100% positive. Let me.
Level of significance, a number that can be used to determine if the p-value is small enough to reject the null hypothesis. If the p is low, reject the null.
So
Yeah, so I was
basically-
confused because it was like, you could just make up the number, and I was like, what? And they're like, you can't make it this or this. I didn't really get it.
When one probability goes up, the other goes down.
So it's okay. It has to do with. Well, okay. So let me think how to explain it without making myself more confused. So, hold on. What do you think, Myra? Can you think of a way to explain it?
You're thinking. Yeah, I had a hard time with this lesson. There's so much contradiction. I found so much contradiction that I was just like, I don't know.
I felt like the way they explained it maybe wasn't very good either. Like
Right.
the sentences themselves don't really make sense.
Yeah.
Well, we'll just have to ask her specifically what that means. But for now, we just have to think of it as a balancing out. When one decreases, the other increases.
Okay.
But we should probably email her and ask her specifically how that relates.
I can put that in my email if you want, and then forward it to you.
That'd be great.
Okay. Sounds good.
Okay. Dos. So A, so design the study. What is the population of the realtors? How did he sample his population? What is his research question? So this realtor, this dude said that the average age of somebody investing in a second property is 47 years old. He wanted to see how accurate that was. He wanted to see in his region if that related to the national average. So he took 15 random clients and wrote down their ages, those people that purchased a second property, and that's how he gathered his information. He randomly took people go ahead.
I called it convenience sampling.
I would think it was convenience.
Okay.
Because he just grabbed whatever was available. He didn't necessarily go out and research.
Yeah.
It was kind of a lazy thing to do. Personally, I think. But
so for B, it asked how he could have done better, basically. So I said he could have used his data on the computer and done like every nth person or whatever, like the other one.
Or he could have done like simple random sampling where he put it all in a database and have them pick out random ones, because it said that he picked out 15 random clients, but we have human error and we tend to pick similarities. So if he did it like simple random sampling, that would have been more accurate data. It would be more random.
Yeah.
All right. So C. Graph, do a histogram. I just inputted the information because I didn't feel like drawing one.
Yeah.
And anyway, 5 descriptive statistics. So the mean, I got 46.7 in a million threes. Standard deviation was 8.27. Variance is 77.923. Minimum is 27. Q1 is 41.5. It keeps on going. Median 49. Q3 53. Maximum 58. That's what I got. I just copied and pasted the descriptive statistics from SPSS. Okay, so D. Making inferences. So I wasn't quite sure about I.
I wasn't either.
So I looked up the answer and it told me, but I don't know why.
I understood it as it's because he only had 15 pieces of data, and it's gotta be greater than 30 or something.
Wait, which one are you talking about?
D. And the first one in D. DI.
Oh, just make an inference?
Yeah, so check the... Since there were only 15 pieces, what will you need to check?
Oh, yeah. So I said you need to see if it's normal, so you do a QQ plot.
Okay, why? Why would you check if it's normal? What would be your
Reason.
logic?
Because you can't do any of the other math unless it's normally distributed.
That's true.
That's what I was thinking.
And he has a small sample size. Okay.
Yeah.
So everybody got that. You make a QQ plot and then check for normality.
Okay.
So 2, state the null and the alternative hypothesis. So I got for the null hypothesis, but that's the mean is 47, and then the alternative is the mean is not 47.
Yes.
Okay. And level of significance.
I put it as two-tailed on that one also.
Oh, good point. Yeah, because it's it's not 47. Okay. So
you two tails because it's not 47.
it's because you have the greater than and less than signs.
Yeah.
And two-tailed, it would just be it's not, so equal. It doesn't equal 47, or it doesn't equal the mean that you think.
Gotcha.
All right.
Okay, so two tails for that one.
Okay. Okay. Oh, I just lost it. Okay. So let the level of significance be alpha is 0.05. That doesn't really tell us anything. We'll
I know.
do that.
Do anything for that. It's just giving you.
Just giving you information. So, compute the test statistic. What formula would you use? So recall our test statistics will be a z-score. So you find a z-score.
I don't know why they call it something different now.
What do you mean?
I was like, just call it the z-score.
Right. But the z-score helps us compute. Well, it is the test statistic. That's what we're trying to figure out.
Yeah.
It's just another
So-
name for a z-score.
When I did it, I got negative 0.207.
I got negative 0.2091.
So they're similar. I didn't do any rounding before I did all the math in my calculator.
I'm good.
I don't know if that makes a difference. What did everybody else get?
I got 0.209.
Did you guys round it all?
I rounded at the end. Let me see if I did my math wrong, because that's happened to me a couple times.
Wait, Candace, what did you get again?
Negative 0.207.
7? Oh, I don't know how you got that.
You're still square rooting the standard deviation by the n, though, right?
You square root the n underneath the standard deviation.
Yeah.
So
Okay.
you found anyway.
When I
Well,
plugged
for my
in,
average that I started with was 46.733.
That's what I got too.
that's
But
what
see, I hadn't.
Let's see.
I didn't start that over, so I kept the 3333333. So maybe that's why it's different.
Yeah, I didn't put that whole thing in there.
I only put 46.73.
That's what I did too.
Maybe that's why our answers are different.
Well, let
Yeah.
me try it again, so that I'm not.
Yeah, I still get the same thing. You guys have it. You divided it by 5 divided by the square root of 15, right?
Yeah.
Yeah.
So
Everybody do it again.
that's what I'm doing right now.
We got just slightly different answers, but. Yeah, so I guess leaving off that extra 3, so if you do it to 3 decimal places, you get 0.207. when I did 46.73, I got 0.209.
Yeah. And
So-
I got 0.209.
Yeah, so because you guys didn't go to 3 decimal places, your answer was different than mine.
Okay. But we all know how to do that. That's the main important part.
Yeah, and it's positive, right?
No. I got a positive number.
I got negative.
Oh my gosh. Okay. Let's try
Well,
this.
because 46.73 minus 47 is going to be a negative number.
Mm-hmm.
But I thought that because the mean is 46.73 and we're asking the sample, or the number we're asking for is 47, so it's 47 minus 43 point, or 46.73.
Oh, then I did it backwards. So
I
you're
always
supposed
do
to
that.
put
I always type it in.
So you're supposed to put the population average, or the population mean, minus your new mean that you think it is.
That's what I thought we were supposed to use we're supposed to use the hypothesis for the X bar.
Okay.
So wait, how would
yeah.
you do it? 47 minus 46.73?
That's what I did.
No. Because the formula would be X bar minus mu divided by sigma divided by the square root of n.
Well, I think the answer sheet gave it as a positive number, so I think you might be right, Jen.
Let me check my math again. Don't.
Just check the answer sheet. That will dispute whatever we say.
Yeah, but I still wanted to make sure everybody gets it right. You know, that we all
Understand.
exactly. So, 15 squared. So it's 0.82744638 divided by that equals. Did somebody pull up the answer sheet?
I'm trying to get it. I can't find it where I downloaded it.
It's
I have it
0.2091, so it's not negative. So you'd use your new mean and minus it from the old one? Is that how you could look at it?
That's what I think.
I think you're right.
Okay.
So the answer that was on the answer sheet was 0.209?
Yeah.
Okay. Sometimes things like this make me wish we had like a classroom setting.
Mm-hmm.
You know, so we could all clear up all our issues at once.
No kidding.
Alright, so then for computing the p-value, I got 0.836.
I got 0.834.
That's what I
Oh,
got.
that's right, because my number was different.
Your number was just a couple. Like your
Slightly
it was
off.
you got 207 and it was
Yeah.
209.
So
So it was that's really close.
So I did the right thing. I just had to remember the number.
0.834, right?
I didn't sketch the curve. I just put it in the applet.
That's what I did.
I didn't. I'm like, well, screw it. I'm just gonna put it in the applet anyway. Okay.
Yeah.
So our p-value is, so for number 4, 5, 6, 6, Our p-value is greater than 0.05. So if you look at the table, we fail to reject the null.
Yeah, that's what I said.
That's what I said.
So for 7, what conclusion do you have to the alternate hypothesis? There's no evidence to prove that it's a different age.
Pretty much.
So, anyway. So, there's no evidence to prove that the age is any different than 47. Mm-hmm. Take actions. I don't know, maybe he should stop targeting younger people.
Yeah, that's basically
what I
said. It was pretty funny. Her answer was just like, he should continue to work in that age division in his business.
Oh, really? That's funny. Yeah, because well, when he uses 15 of his clients, I mean, you're not going to get an accurate sample.
Yeah.
Mm-hmm.
You need hundreds to do that.
Yeah, for sure.
Anyway. Okay. We all good with that?
Yeah, so we can take the
Sure.
Okay. Every time I get a little nervous.
Yep, I don't even like this chapter, so.
It's just a little bit finicky, it feels like. It's very temperamental, whereas the other ones were a little bit more
I think they're
straightforward.
trying to tell you the basics of it without going in depth, but now it makes no sense.
Yeah.
Right. They need to do a little bit more.
Yeah, they should spend time on just the p-value and level of significance, and then introduce errors at the next section or something where you can actually go in depth on what you're talking about.
Yeah.
Yeah.
Well, when I took this class the first time, we didn't talk about this till towards the end of the class.
Oh,
Oh, really?
Yeah, we had like 6 weeks left in school when he started talking about it. Well, like a month left. And so he spent a lot of time on the other stuff and didn't spend as much time on this stuff.
Yeah. Well, when I started looking at this chapter, I was like, did we skip something huge? Because it was completely new information, that we haven't slowly started to look through, as opposed to the other chapters where we slowly get into the next section.
Yeah, for sure.
All right.
Okay, so number 3. Oh, sorry, open the group quiz. Are you guys all ready?
Yes.
So the hypothesis test consists of 2 hypotheses, the null and the alternative hypothesis. Which one is the status quo? The null.
The null.
Which hypothesis involves equality?
The null.
The null. It's the only one that I'm going to know, so I'm excited.
The p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed when computing the... I think it's a null.
Yeah,
null.
you assume that one true. Yeah.
Just think of a court case. You're innocent until proven guilty.
Exactly.
Got it.
You have to prove that it's wrong. You can't...
Yeah.
You would just assume it's correct. Okay, so 6.
I said C on 6.
Yeah, not equal to because it's 2 tails.
I agree. 7.
So left-tailed would be less than,
I agree.
Yeah.
and then right-tailed would be greater than.
I always have to think of the alligator because I struggle.
Okay,
with
cute.
How about
Alligator.
A, B, and C's, because I'm retarded right now.
these.
It's
7 we
bedtime.
put A, and then 8 we put B.
Okay, sweet.
Okay, so 9.
Outcome of
It would
a...
be A, wouldn't it?
Greater.
So I think less than.
Is it?
I think greater than the p-value.
I was I think
Let's
it's
look at
greater.
our notes. Let me pull it up. So that we know for sure. I'm not guessing.
Maybe I'm thinking
So
backwards.
it's fail to reject the null.
Oh, right here. I have it written down. You
Okay.
reject the null if the p-value is less than x. So you're right.
It'd be
So
great.
it's... Okay, so... got it.
So it's A, right?
Yes.
Yeah.
The relationship would result in rejecting the null. It would be
Less.
less. Yeah.
I don't get really why, but I wrote that down. So.
There you go.
So I believe myself.
Vanderbilt.
Oh, she is so into that movie. I love it.
Hi, Vanderbilt.
Okay. So,
Vanderbilt.
instructions foreign policy. 1500. They are concerned with the truth.
Okay, Vanderbilt.
Appropriate. Greater?
Yeah, that's what I think. Because it says
Actually,
Wait,
higher.
Yeah, it's higher, so it'd be greater.
They,
that we see
in the
11.
third.
Oh, okay.
And 12 would be A. The average claim amount is equal to 1,500.
Yeah, the null is equal.
Yes.
Okay. That makes sense.
13.
The insurance company assumed the distribution of samples is normal. Is this a good assumption? How do I know if it's a good assumption?
Because
yes.
didn't we just say earlier that it had to be over 30 or 30
Yeah.
or more?
Oh, that's right. Yeah.
So okay. So 14.
So it's always over 30 then?
So that means the insurance comes. It's yes, right?
Yes.
Yeah.
Correct.
Yeah, so this builds off what we learned last time. Remember, if it's the parent population is normal or the group sample size is over 30, then it's normal.
Then it's normal, yeah.
And that's the central limit theorem.
Yes.
Something
15.
familiar.
Mm-hmm. So 15, the test statistic is the z-score. We talked about that.
I know. I don't know why they gave it a new name, but whatever.
It sounds better when you're talking about crap.
So now we have to calculate the z-score.
So
we figured out last time that you put the original mean first.
well, it gives you the x-bar. So she will use the level of significance. Alpha is 0.05. She then takes a simple random sample of 36 sales receipts from her and computes the x-bar is $144.
Oh, shoot. So it's 144.
So I got 0.9.
Mine is...
I did too.
That's it?
Wait, hold on.
But we have to do it to the third decimal place.
Well, it says round to the third decimal place. We don't have a third decimal.
But you can put zeros.
I guess.
Wait, what did you guys get?
0.9.
Okay, yeah, I got.
Hold on. I got negative 0.9.
That's what I got.
What number did you put?
I got positive.
Because they give you the x-bar, so I just put that number first.
So I did one.
Minus it by 150.
But on the homework, didn't we figure out that you have to put the new mean second?
So 150 minus 144 is what you're saying?
Yeah, because that's what it was on the homework, and that was the right answer.
That way it comes out positive.
Yeah.
Yeah, but
It gives you the X bar though.
that's why I'm concerned.
So you need to just plug in what it says. If the X bar is 144, you need to put that into the formula.
Negative
Or I'm confused.
That doesn't make any sense now, because the homework, it was the other direction.
Hold on. Yeah, I still got negative because I don't know. Maybe we should
No, I
ask
see
her.
your point, because that's how the formula is written. It's just frustrating, because on the homework, or on the preparation, it has to
did it differently. No, I
It
see what
came
you're
out
saying.
positive.
I could put that in the email.
Yeah. Maybe we should just clarify exactly what she wants us to be the x, what the x bar is, when they don't tell us specifically that this is the x bar.
So are we going to put it as a negative 0.9 or?
I would.
I would just try for that, since that's what we originally got.
I would put negative because this says that it is the x bar, and the formula says the x bar goes first.
Okay.
Right. That's what I think. But okay. So let's go to the applet for the next one. And then negative 0. Oh. And negative 0.
So for this, since it's got to be great, we're saying it's greater than, it would be highlighted in the middle and then to the right, right?
Well, they think that the average has decreased.
Oh, let me see. Am I reading it wrong? Okay.
So I would say just less than.
Yeah.
And I got 0.1841.
That's what I got.
Me too.
Highlighted on the right.
4.
Yeah.
Okay, me too.
So we would fail to reject the null because it's greater than 0.05. Yeah?
Wait. Yeah.
Okay. 2 types of errors that could be, which one rejects the null when the null is true? That would be a type 1.
Yeah.
Type 1. Yes.
20. Oh, we talked about this, the significance. So that significance is decreasing, so the probability of a type 2 error would increase. Yeah?
Yes, yes.
Yeah, see, this was a part that didn't make sense in the reading, where it was like, I'm just going to change the level of significance. And I was like, I don't get how you can do that.
I think they were just doing it as an example, not to, I don't know, just show you what it would do in this situation, not specifically let me manipulate the data so that it can do what we want.
Alright, I don't know how to do this last one.
Okay, let me go to my notes. Okay, it says here, a level of significance of alpha is 0.05 seems to strike a good balance between the probabilities of committing a type 1 versus a type 2. So I think that it would be 0.05.
Oh, that's just like that question. Oh, I see.
Wait, I don't get it.
It's like the question on the preparation that was like, if there's a 0.01, what's the chance of that happening? It's that exact same question. It just, I'm on ended test mode. So
Yeah.
yeah, in C. Yeah, I'm like over here looking for a formula.
Yeah. That's what I was doing.
Does that make sense?
Oh, that makes sense. Yeah. Okay.
Because I think that's just what I think. If you guys disagree with me, then that's fine. Should we go through them all?
Yes.
Sure.
So number 3 is null. 4 is null. 5 is null. That's weird that they're all 3 nulls.
I know.
6 is mu is not equal to 10, so equals /.
So C.
Yes. Are they mixed up or are they always in order?
This one, they seem to be in order.
Yeah.
So 7 is A, which is less than 10. 8 is B, which is greater than 10. 9 is A, greater than alpha.
Wait a minute. 7 you put mu is less than 10?
Yes.
Okay. And then for 8, you put mu is greater than 10.
Mhm.
Okay.
Yeah.
So, 10
making
is
sure.
alpha is, no, that's great. Is alpha is larger than the p-value, which is B. 11 is the average claim amount is greater than 1,500, which is C. 12 is A, is equal to 1,500. 13 is yes. 14 is central limit theorem. 15 is Z, which is C, or which is B. Z, B. 16 is, say that again? 16 is negative 0.9. 17 is 0.184. 18 is fail to reject the null. 19 is type 1. 20 is the probability of a type 2 error will increase, which is B. 21 is 0.05.
Yep.
Okay, let's submit.
Yes.
Woohoo! We did it.
For not understanding, you did a very good job.
I would say.
Well, because
I know, right? There are like 3.
Well, in certain aspects, some of us understand other parts. You know what I mean? Like we filled in each other's gaps
Yeah.
for the most part.
Yeah. I just couldn't keep and study this.
Yeah, I couldn't do the test on my own.
Yeah,
So I
I'm
went
still
through
gonna
this.
like. Yeah, I'm gonna have to go over this again because I'm still.
Yeah, it's not. I can't take the homework right now.
Yeah. It's not that bad though. The test, it wasn't that bad. It was pretty. It was a lot like the homework and the
really?
quizzes that we've taken. Yeah.
That's good.
Okay.
So
How many
there
problems?
was 33.
Oh, that's
fine.
33, yeah, so it wasn't bad. Yeah, it wasn't a breeze just because I am super, super slow. I am always like the last one in a real class, so, but it
How long
wasn't
did it take
bad.
you?
I don't even remember just because I was stressed about the whole SPSS, so a long time, longer than it should have.
Were there multiple choice and fill in the blank?
Yeah,
There
both of them. There were more multiple choice, but yeah.
That's refreshing, though. Usually I can
It
get
is.
multiple choice.
Yeah.
Yeah. I love
It's
multiple
like-
choice, but yeah, the last ones were like the last like 6 or 7 were like fill in the blank, but it's the stuff that we've already done, so.
That's nice.
awesome.
But yeah.
All right, so next Monday.
Yep. Good luck
Yes.
on the
Can-
test, everybody.
Can we do it a little bit later next Monday?
Yeah, we can do that.
So like 9 my time, is that okay?
So 7 our time and 6 Steph's time. That's fine. We can do that.
Okay.
All right. Sounds good, you guys.
Thank
All right.
you guys.
Right.
Bye.
Good luck tomorrow.
Thank you.